Our next speaker is Kyle Barron, and Kyle is going to talk to us about yspec, which is an R package to create and deploy dataset specification objects in modeling and simulation workflow. Kyle, take it away.
Okay, thank you. Yeah, so today I'm going to tell you about yspec, and this is a little package that we've been using for documenting model-ready analysis data sets. So the context here is that we work in pharmacometrics, and so we're doing hands-on modeling and simulation all day long, and so we're constantly creating like model-ready analysis data sets. So a sponsor will, for example, send a source data that might be in Atom format. We'll do a data assembly step where we turn that into analysis-ready data set, like a data set that could go right into non-mem. And for each data set that we create like that, we have to create a defined.pdf file that says what's in that data set and how did it get put together. So we track things like the column name and the column order. We'll put a label in there that's a short description of what the column is. Column data type, is it numeric, is it character? And the scopes, so for example, for discrete data, we'll say what the valid levels are in that column, and then maybe a decode or a label that describes what those levels are. And there's a little example down at the bottom of the slide here. So before we started this project, we didn't have a great way to do it. There's maybe 3 or 4 different ways, and none of them were really great. We want to avoid just typing this information into a Microsoft Word document. That's sort of a dead end for this data set data or these data attributes. We wanted to be able to handle it programmatically. We wanted to specify these attributes just once, so if we could put them into a central location and then draw on these data set attributes, not only for rendering that defined.pdf file, but maybe pull some of that information in as we're making plots and tables and things like that. And we wanted, obviously, just to be really as easy as possible to do the data entry part of this process. So we did what everyone else does. We appealed to YAML. The Y in yspec stands for YAML. So when you want to document an analysis data set, you create a file that's coded in YAML syntax that I'll show you, where you declare the data column names and the attributes, and all that is basically in a YAML syntax. We can read that in with a YAML parser, and you get an object in R that you can work with. It's a list, or actually a list of lists. And when we can go into that list, extract different of those attributes to get that column data back. We can validate our data set against the data specification object. So if I've got my data set in a data frame format, I've got the data specification object, I can compare those two, and yspec will tell us where my data set isn't in conformity with the specification object. And then we can also enforce different standards and requirements. So for example, we might want all the column names to be less than or equal to 8 characters long. And then we can use this data specification object to template that defined.pdf document. So the next 2 slides, I'm just going to show you some of the YAML syntax for doing the data set documentation. So I'm going to open up a file called nmdata.yaml. And then at the top, or I'm going to have like one block where I can enter in metadata for the data set. So things like description, sponsor, project number, something that we use in documentation. I wanted to point your attention to this use internal database. And so we have data columns that just very frequently appear in our data sets. And we wanted to have a standardized way of talking about those data items. And so we created this little internal database that's inside the yspec package. And when users are creating their data definition document, they can inherit those attributes into their own data specification. So they're using that same sort of standardized language that we'd like them to use. And they can also create a project-wide database. So for example, there might be an endpoint that's specific to a specific project that we want to talk about in a certain way, and we want that to be standardized across all the different data sets where that endpoint might end up in. So the PK data, the PK/PD data, or the adverse event data set. And so you could inherit from that project-specific database as well. And that enforces or just helps to encourage a consistency between data sets within a project and then between projects. So the next slide is just a little bit on documenting different columns, and I'll just have you go to the bottom here. These last two columns, I'll kind of walk you through. There's a column named seek or sequence. That has a short name called data type, and that can take one of two different values. So 0, which means an observation, or dose, which or 1, which means a dose. And so we've got kind of levels here to be 0 or 1, and we've got labels, which are observation and dose. So that's sort of a discrete data type. That weight I'll use as a continuous data type. So I've specified the range here. So I said weight could reasonably range between 40 and 140, those values. And I've specified this lookup handler. So this is a YAML handler, and that just basically gives yspec permission to go into that internal database, inherit all the other parameters that I want to come with weight, and all that's going to show up in the data specification object. So again, those last two screens, we're going to type that into nmdata.yaml. We can load that, parse and load that into our R session. Now I've got an object called spec, and I can say spec $weight, and I can see what those attributes are. So I can see that weight is numeric. It's subject weight at baseline, and it has a unit kilograms. So all that came from that internal database, and that's that sort of that standardized way that we want people to talk about weight maybe. And then I've kind of augmented that with that range that's kind of specific to my project here. A little bit more complicated example, there's another column called RF, and I can say spec $RF. I can see that that's an integer value that stands for renal function stage. And there's 4 valid values for that column. So 0, 1, 2, and 3. And 0 meaning normal function, 3 meaning severe impairment. And so as I'm coding the data set, I've got this object lined up in my R session. I can just quickly say spec $RF and just say, oh yeah, it was 0, 1, 2, 3, not 1, 2, 3, 4. And I can say, oh, what was RF value equals 2? Oh yeah, that's right, that was moderate impairment. So hopefully this is really interactive and useful as we're kind of working in our R session. And so again, we've got levels here to be 0 through 3, and we've got labels, and we can use this information to augment our data set. So I've kind of got an example at the bottom here of an API function where it's ys add factors, and so I can pass in a data set, I can pass in the data specification object. And what that's going to do is that's going to go through that spec object, it's going to find RF there, it's going to say, oh, RF has both levels and labels, it's going to augment my data set, it's going to add a factor version of RF called RF_F. And it's going to use the levels 0, 1, 2, 3, and it's going to have these nice labels. And so if I add these factors, now I've got an augmented data set. And then when I go to make a plot and I want to facet it by renal function stage, I don't need to, I'm not going to use RF here, which would be 0, 1, 2, 3, but I want to use RF_F, and I can take advantage of these nice labels and these nice decodes. Just a reminder that the spec is still just a list and you can interact with it. So if I'm wondering what the time unit was in my data set, I can just say spec $time $unit, and I can see its hours. And then other ways that you'd interact with a list through different per functions. And we've got some other API functions that are sort of listed down here as well. So finally, creating that define document. We've got a couple different documents that we can make. I'll show you the one that we use for regulatory submission function called ysDocument. I can pass in that data specification object along with some other metadata. And then I'll just flip over to the document here. I can get this, this uses our Markdown to render this document. Here I've passed in a couple of data sets here, and it'll kind of collate all those into a single document. I've got the PK data here, POP-PK analysis, and I've got an adverse event data set as well, and those are all kind of listed out into the single document. I can link down to this and I can see what the variable names are, what the labels are, the units, and all that information that we wanted to get back. And I'll scroll back up to renal function here, and this is all that information that we get back in this defined document that we can ship with that analysis ready data set. Yeah, so that's yspec in about 10 minutes. Thank you to the our Pharma organizers for allowing me to present, and then I've got a link to the contact information at the bottom of the last slide here. Thank you.
Thank you, Kyle, for that presentation about yspec.